The night sky has always felt like a finished map, a steady arrangement of stars and voids that we believed followed a predictable rhythm of birth and decay. We lived with the quiet certainty that the early universe was a slow, dark nursery, a place where gravity labored for eons to pull thin mists of hydrogen into the first fragile embers of light. In this version of history, the dawn of time was a patient process, an era of gradual assembly where galaxies took their time to grow from nothingness into the luminous cities we see today. But that certainty is gone. A single point of infrared light has emerged from the deep field to dismantle everything we thought we knew about cosmic evolution. It is called JADES GSZ14-0. This galaxy should not exist. According to every standard model of how a universe matures, it is an impossibility, a ghost that arrived far too early to the party of existence. It sits there in the silence of the void, defying the laws of stellar growth by being far too massive and far too bright for its age. While our theories predicted a chaotic fog of primordial gas, JADES GSZ14-0 appeared as a fully realized powerhouse, forged with an intensity that suggests the universe was capable of creating complex structures much faster than we ever dared to calculate. It is not just a discovery, but a quiet betrayal of our cosmological maps, proving that the first fires of the cosmos burned hotter and sooner than any equation had predicted. The existence of this single entity forces us to rewrite the timeline of the beginning, shifting the boundary of what is possible in the dark. We are now looking at a light that has crossed a distance so vast, it defies human intuition, traveling through an expanding vacuum for more than 13 billion years just to reach a mirror of gold and beryllium. To grasp the scale of this discovery, we have to move beyond the maps of distance and enter the realm of redshift. In the language of the cosmos, light is not a static thing. It is a stretching fabric that carries the history of the universe within its waves. As space itself expands, the light traveling through it is pulled, stretched from the energetic blue of a hot star into the long, tired wavelengths of the infrared. This stretching is what astronomers call redshift. For JADES GSZ14-0, that stretch has reached a record-breaking point. It carries a confirmed spectroscopic redshift of ZD equals 14.32. To a casual observer, this number seems small, but in the geometry of the early universe, it is a staggering distance. A redshift of 14.32 means the light we are seeing today has been stretched by a factor that places this galaxy further away than any other confirmed entity in the history of human observation. It is the furthest spectroscopic window ever opened into the deep past. The journey of these photons began when the universe was an infant, and they have spent more than 13 billion years crossing a void that grew larger even as they traveled through it. Think of the sheer endurance of a single particle of light. For over 13 billion years, it flew through absolute nothingness, passing through regions of space that had no stars, no planets, and no warmth. It traversed billions of light years of expanding vacuum, surviving the cooling of the cosmos and the birth of countless other galaxies, all to eventually collide with a mirror of gold beryllium orbiting our own sun. This is not just a measurement of distance, it is a journey through time itself. When we look at JADES GSZ14-0, we are not seeing the galaxy as it exists now, but as it was in its first breath. We are peering back to an era when the very concept of a galaxy was still being written into the laws of physics. The light has traveled so far that by the time it reached our instruments, the universe had expanded and aged into the vast, cold expanse we recognize today. The distance is almost impossible to visualize because it exceeds the limits of human intuition. If you were to imagine the entire observable universe as a sphere, JADES GS-Z14-0 sits at the very edge of that sphere, pushing against the horizon of what can possibly be seen. It exists in a slice of time so remote that everything we see around us, the Milky Way, Andromeda, the local clusters of stars, had not yet begun to form. The light from this galaxy began its journey when the cosmos was barely a flicker of its current age, crossing 13 billion years of emptiness to tell us that something was already there. The record redshift of 14.32 serves as a coordinate for the absolute limit of our vision. It marks the boundary where the known universe ends and the mystery of the first light begins. By confirming this distance through spectroscopy, we have moved past mere guesses or probabilities. We are no longer looking at a smudge of light that might be distant. We are looking at a confirmed anchor in the deep past, a lighthouse burning in an ocean of primordial dark. This distance creates a profound sense of vertigo. We are witnessing a ghost, a reflection of a powerhouse that lived and breathed 13 billion years ago, sending its image across the vacuum like a postcard from the dawn of time. The sheer scale of this travel means that for every single photon we detect, billions more were lost to the void, scattered by the expansion of space. Yet, enough survived to reach us, carrying with them the secret of JADES GS-Z14-0. As we stare into this record-breaking distance, we are forced to ask how such a thing could be visible at all. To see something at ZE equals 14.32 requires more than just a powerful telescope. It requires a way to pierce through the darkness of 13 billion years and capture light that has been stretched almost beyond recognition. The question is no longer where this galaxy is, but how we manage to find it in such an immense, unfolding silence. The distance is not a line we can draw on a map, but a weight that settles upon the mind when you truly attempt to feel it. Imagine the silence of those 13 billion years. It is a silence so absolute that it swallows entire eras of existence. For the light leaving JADES GS-Z14-0, there was no destination for eons, only an endless, stretching corridor of blackness, where the very fabric of space was expanding beneath its feet. Every kilometer gained was a victory over a void that sought to dilute it into nothingness. Think of the patience required for such a journey. We often speak of light as instantaneous, but across these scales, light becomes a weary traveler. It has crossed distances that make our own galaxy seem like a single grain of dust in a cathedral. To reach us, this radiation had to survive the chaotic shifting of the early cosmos and the slow, cold drift of the Middle Ages of the universe. It flew past nascent nebulae and through regions of space where not a single atom of matter had gathered for millions of years. If you could stand at the edge of that distance, looking back toward the source, you would see a horizon that curves away into an impossible depth. The light we capture now is exhausted. It has been stretched by the expansion of the universe, its waves pulling apart like taffy, shifting from the energetic ultraviolet of its birth into the long, tired infrared wavelengths that only our gold mirrors can perceive. This stretching is the signature of a universe that refuses to stay still, a cosmic tide that pushes everything away from everything else. This journey means that JADES GS-Z14-0 exists for us as a memory written in photons. The galaxy we see may have changed beyond recognition or vanished entirely into the maw of a black hole billions of years ago. Yet its image continues to drift through the vacuum, oblivious to the passage of time. We are catching a glimpse of a ghost that has been flying toward us since before the first stars in our own neighborhood were even imagined. The sheer endurance of this light is what allows us to bridge the gap between our fragile present and that primordial dawn. It is as if we have found a single ancient thread, connecting two shores of an ocean so wide that no ship could ever cross it. The photon does not tire, but it carries the burden of everything it has witnessed: the cooling of the gas, the birth of the first clusters, the slow unfolding of the cosmic web. When this light finally collided with the beryllium mirrors of our instrument, it was a collision 13 billion years in the making. A journey that began in a universe so young it was still glowing from its own creation, ending in the cold precision of a detector orbiting far beyond the reach of Earth's warmth. The distance is not just a number on a chart, it is the measure of our own insignificance and our incredible capacity to look back into the dark and see that we were not always alone in the silence. We are staring at the very edge of the observable, where the light from the beginning of time finally runs out. Beyond JWST Z14-0 lies a wall of darkness, where the universe was still too opaque for light to travel. This galaxy sits precisely on that threshold, a solitary beacon marking the transition from total blindness to the first flicker of sight. It is the furthest anchor we have ever found, holding us steady as we peer into the abyss of our own origins. Expectation, a universe that began as a chaotic and silent mist of hydrogen. For millions of years after the first spark, we believed the cosmos was a dark nursery where gravity worked with agonizing slowness to pull thin veils of gas into the first fragile clumps of matter. In this version of history, the early dawn was a period of hesitation. The first stars were supposed to be lonely, small and dim, flickering into existence one by one in an ocean of absolute blackness. We expected a gradual climb toward light, a slow accumulation of mass that would take eons before anything resembling a true galaxy could possibly form. Reality, JADES Z14-0. When the data arrived, it did not show a fragile flicker or a hesitant clump of gas. It revealed a luminous powerhouse. This is a galaxy that does not just exist. It dominates its surroundings with an intensity that defies every standard cosmological model we have built to explain the beginning of time. Its intrinsic luminosity is far superior to anything predicted for this epoch. According to the models, a galaxy at this stage of cosmic history should be a ghost, a faint, barely detectable smudge of primitive stars. Instead, JADES Z14-0 burns with a brilliance that suggests a level of maturity and energy production that simply should not have been possible so soon after the Big Bang. It is as if we expected to find a small campfire in the wilderness, but instead, we stumbled upon a sprawling city of light. The discrepancy is not a minor error in calculation. It is a fundamental clash between our theories and the physical evidence. The luminosity detected by the instruments suggests that this galaxy had already managed to gather an immense amount of matter and ignite it into stars at a rate that shatters our understanding of early cosmic evolution. How does such a powerhouse assemble itself while the rest of the universe was still waking up from its dark sleep? We are looking at an entity that has bypassed the slow, patient growth we attributed to the first galaxies. While the standard models predicted a quiet transition from darkness to light, JADES Z14-0 represents a violent acceleration. It is a beacon of efficiency and power, forging starlight with an intensity that suggests the laws of accumulation were operating differently in the deep past. The sheer volume of photons escaping this galaxy tells us that it was not just forming stars, but producing them in massive, concentrated bursts, creating a luminosity that cuts through 13 billion years of void, as if the distance were nothing. This brightness is a signal of something deeper, a hidden history of mass and gravity that we have yet to map. The standard cosmological model assumes a certain speed limit for how quickly gas can collapse into stars, and how quickly those stars can cluster into galaxies. JADES GS-Z14-0 has ignored that limit. It stands as a luminous anomaly, an object that possesses more energy and light than the sum of its predicted parts. The scale of this luminosity forces us to reconsider the very nature of the cosmic dawn. We are no longer looking at a slow awakening, but perhaps a sudden explosive birth, where certain regions of space became factories of light far faster than we ever imagined. The void was not as empty as we thought, and the darkness was not as absolute. There were pockets of intensity, places where gravity worked with an unexpected ferocity to build monuments of starlight in the blink of a cosmic eye. We are left staring at a contradiction written in light. On one side is the mathematics of our models, which tell us that such luminosity should be impossible at this distance. On the other side is the raw data from the deep field, showing a galaxy that burns with an impossible brilliance. The evidence does not ask for permission to exist. It simply sits there, 13 billion years away, challenging every assumption we held about how the first lights of the universe were lit. The luminosity of JADES GS-Z14-0 is more than just a number in a paper. It is a rupture in our narrative. It tells us that the early universe was capable of producing massive, luminous structures while it was still in its infancy. The transition from the Dark Ages to the Age of Galaxies was not a smooth slope, but perhaps a series of jagged leaps, with JADES GS-Z14-0 representing one of the most extreme jumps of all. To see this luminosity, to capture these specific photons that have been stretched by the expansion of space for billions of years, required something more than just a lens. It required an instrument capable of seeing what is invisible to every other eye in human history. The light from JADES GS-Z14-0 had shifted far beyond the visible spectrum, sliding into the deep infrared, where it hid from our previous telescopes. To find this powerhouse, we had to build a specific eye that could pierce the darkness. To find a ghost from 13 billion years ago, we had to stop looking for light as we know it. The photons leaving JADES GS-Z14-0 were born as fierce ultraviolet energy, the kind of violent radiance that marks the birth of massive stars. But space is not a static void. It is an expanding fabric. As those photons traveled across the widening gulf of the cosmos, they were stretched. Their wavelengths grew longer and longer, shifting from the sharp blue of ultraviolet into the deep red, and finally sliding entirely out of the visible spectrum. By the time that light reached our solar system, it had become infrared radiation, a faint, invisible heat signature drifting through the dark. This is why every telescope that came before was blind to this specific dawn. To capture a signal so stretched and so weary from its journey, we needed an instrument designed not for sight, but for detection. We needed the NIRCam. The near-infrared camera on the James Webb Space Telescope does not see the universe in colors our eyes would recognize. It operates in the silence of the infrared, sensing the subtle glow of heat and shifted light that has spent eons crossing the vacuum. For JADES GS-Z14-0, NIRCam acted as a cosmic filter, stripping away the foreground noise of closer stars and galaxies to isolate a single, impossibly distant point of luminosity. The process is a patient one. The camera stares at a seemingly empty patch of sky for hours, absorbing an infinitesimal amount of light. It collects photons that have been traveling since the universe was less than 300 million years old, gathering them on detectors cooled to temperatures colder than the deepest reaches of space. This extreme cold is necessary because any heat from the telescope itself would drown out the signal. If the instrument were warm, it would be like trying to hear a whisper in the middle of a hurricane. When NIRCam finally locked onto JADES GS-Z14E0, it didn't find a smudge or a blur. It found a source of light that was far too bright for its era. The detection capability of this camera allowed us to see the galaxy not as a theoretical possibility, but as a concrete object with a measurable brightness. We could see the way the light clustered, the specific intensity of its glow, and most importantly, how it differed from everything else in the deep field. The images produced by NIRCam are more than just photographs. They are maps of time. Each pixel represents a different slice of history. By comparing different infrared filters, astronomers could see that JADES GS-Z14E0 was missing certain wavelengths of light, a phenomenon known as the dropout technique. The galaxy vanished in shorter wavelength filters and reappeared only in the longest ones. This specific disappearance is the fingerprint of extreme distance. It told us that the expansion of space had pushed this galaxy's light so far into the red that it had simply fallen off the edge of our previous maps. There is a quietness to this discovery. There were no alarms, only the slow realization as the data processed through the NIRCam sensors. The team watched as a dot appeared where there should have been nothing but void. They saw a luminosity that defied the standard models of how fast matter could clump together after the Big Bang. The camera was showing them something that the math said shouldn't be there yet. We often think of telescopes as windows, but NIRCam is more like a time machine made of gold-plated beryllium and silicon. It allows us to reach back into the era when the first structures were coalescing from the primordial mist. By capturing this infrared glow, we are essentially catching the last echoes of the universe's first fires. The light from JADES GS-Z14E0 is a fragile thing, stretched thin by billions of years of expansion. Yet it carried enough energy to trigger the sensors and rewrite our history. The sheer sensitivity of the NIRCam allows us to perceive the galaxy as a compact powerhouse, a concentrated knot of stars burning with an intensity that seems misplaced in such a young cosmos. It is a singular point of defiance against the dark. We can see its silhouette against the blackness, a tiny island of light in a sea of hydrogen and helium. But seeing a dot of light, no matter how bright or how distant, is only the first step. A photograph tells us where something is and how bright it appears to be, but it cannot tell us what that object actually is. It cannot tell us if we are looking at a true galaxy or some other cosmic anomaly. To move from an observation to a fact requires more than just a picture. But a picture is not a proof. To grasp the distance of JADES GS-Z14E0, we must stop thinking of space as a map and begin thinking of it as a journey for a single particle of light. Imagine one lone photon, born from the heart of a star in that distant galaxy, beginning its long walk across the void. This tiny packet of energy did not simply travel through space. It traveled through time itself, crossing an abyss so vast that our minds naturally recoil from the number. For more than 13 billion years, this single photon moved through the expanding dark, passing through regions of emptiness where no other light existed to guide its way. If we were to shrink the entire observable universe down to the size of a city, the distance this light traveled would be like crossing an infinite desert on a grain of sand. It is a journey that exceeds our most basic instincts for scale. How does a single point of light maintain its integrity across such a staggering span? What happens to a beam of energy when it must survive the stretching of the very fabric of reality for 13 billion years? We are not seeing JADES GS-Z14E0 as it is now, but as it was in a flicker of cosmic youth. The light we capture today left its home when the universe was still a fragile infant, long before our own sun existed, long before the Earth was even a cloud of dust in a distant corner of a different galaxy. This photon has been traveling since the dawn of time, carrying with it a coded message about the conditions of the early cosmos, enduring the relentless expansion that pushed its wavelength further and further into the infrared. It is a fragile bridge made of light, spanning 13 billion years of silence. The vacuum of space is not truly empty, but for this photon, it was a gauntlet of expanding dimensions. Every kilometer it traveled added to the tension of its journey, stretching the light until it became a ghostly whisper that only an instrument as precise as the JWST could ever hope to hear. We often feel the weight of a few decades or the span of a human lifetime, but here we are touching a ghost from a time when the universe was barely 290 million years old. The distance is so great that it ceases to be a measurement and becomes a form of silence. It is the kind of distance that makes everything we know feel small. Yet it is exactly this bridge of light that allows us to look back into the mirror of our own origins. We can almost feel the exhaustion of that light as it finally strikes the gold-plated mirrors of the telescope, ending a voyage that lasted longer than the current age of most stars in our local neighborhood. It arrived not as a shout, but as a faint, reddened glow, a postcard sent from the edge of existence and delivered 13 billion years late. But while NIRSpec gave us the image, it only provided the suggestion of a discovery. A dot of light can be many things. It can be a foreground object or a fluke of the sensor. To turn this ghost into a fact, we needed more than a photograph. We needed to dissect the light itself, to break it apart, and read the chemical signature hidden within its frequency. The moment the data became undeniable was approaching. Imagine the absolute silence of that transit. For those 13 billion years, this photon was a lonely traveler in a void that was not just empty, but growing. As it moved, the very space it occupied stretched, pulling at the light, elongating its wave like a piece of glass being drawn out by an invisible hand. It began as a sharp, energetic pulse of ultraviolet radiation, a violent birth from the heart of a massive star, but the journey stripped it of that intensity. By the time it reached our shores, it had been softened, reddened, pushed far beyond the visible spectrum into the deep infrared, becoming a ghost of its former self. What does it mean to travel for 13 billion years? It means passing through eras where entire galaxies were born and died in the periphery of its path. This single packet of energy witnessed the slow assembly of the cosmic web, drifting past the first great clusters of matter that began to pull themselves together under the relentless weight of gravity. It crossed regions of space so desolate that if you were to float there, you would see nothing in any direction for millions of light years, just a crushing, velvet blackness that seemed to swallow all hope of an ending. We often speak of distance as a line on a map, but for this light, distance was a transformation. Every million years of travel shifted its frequency, sliding it further and further away from the colors we can see with our eyes. It became a secret, hidden in plain sight, waiting for a mirror that could finally translate its wavelength back into something we could understand. The photon did not fight the expansion of the universe. It flowed with it, becoming a living record of everything the cosmos had done since that light first broke free from JADES JWST 14.0. Think of the patience required for such a voyage. While empires rose and fell on a distant blue planet, while mountains were pushed toward the clouds and oceans carved deep canyons into stone, this photon was still moving. It did not tire, it did not slow, yet it carried the weight of an entire epoch within its vibration. It is a fragile thread, connecting us to a version of reality that no longer exists, a bridge across a canyon so wide that our mathematics can describe it. But our hearts cannot truly feel it. The vacuum was not merely a stage, but a gauntlet. The light had to survive the turbulence of an expanding universe, navigating the thin curtains of primordial gas and the gravitational wells of unseen dark matter. There were moments in its journey where it nearly vanished into the background noise of the cosmos, becoming so faint that it was almost indistinguishable from the cold radiation left over from the Big Bang itself. It survived by a margin of absolute precision, a miracle of physics that allowed a sliver of information to persist across the abyss. When we look at the data now, we are not just analyzing light. We are touching the hem of eternity. We are interacting with an object that has been traveling since before the first heavy elements had even settled into stable clouds. The sheer duration of this flight creates a kind of cosmic vertigo. It forces us to realize that our entire history, every war, every discovery, every breath ever taken by any living creature on Earth, is but a heartbeat in the lifespan of this single photon's journey. It is as if the universe decided to save one specific memory and send it across the dark, knowing that billions of years later, someone would build a golden eye in the silence of Lagrange Point 2 just to catch it. The light did not know where it was going. It simply obeyed the laws of motion, gliding through the emptiness until it finally found its target. And as it struck the sensor, it brought with it the scent and the heat of a galaxy that existed when the universe was still waking up from its first deep sleep. The transition from a photograph to a proof is where the silence of the laboratory becomes heavy. When the team first saw the candidate for JADES GS-Z14-0 through NIRCam, there was an electric current of anticipation, but it was tempered by a deep professional caution. In astronomy, a red dot on a screen is a promise, not a fact. It could be a cosmic fluke or a closer object masquerading as something ancient. To truly know, the astronomers had to move beyond imaging and enter the realm of spectroscopy. They needed to capture the light and stretch it across a prism, breaking the ghost into its constituent colors to see if the universe was actually speaking back from the dawn of time. This is where the JWST near-infrared spectrograph, known as NIRSpec, entered the frame. If NIRCam is the eye that finds the target, NIRSpec is the mind that analyzes it. The process is a slow, patient gathering of photons, each one a tiny piece of evidence that has traveled for more than 13 billion years. For hours, the instrument stared into the void, collecting the faint, reddened glow and slicing it into a spectral fingerprint. When the data finally processed and appeared on the monitors, the room did not erupt in cheers. Instead, there was a sudden, profound quiet. The astronomers who had spent their careers studying the early cosmos looked at the graph and went very still. They were seeing a redshift of Z equals 1432. It is a number that seems simple on paper, but to those who built the models of how galaxies grow, it was an impossibility. A redshift of 14.32 means the light has been stretched so far by the expansion of space that it no longer resembles the light that left the galaxy. It confirms that this object existed when the universe was a mere fraction of its current age. The team did not celebrate immediately because the number was too high to be comfortable. They refocused the data, checked for sensor noise, and ran the calculations 3 times over, hoping they had made a mistake. They wanted the error to be there, because if the redshift was real, then the timeline of everything they knew about cosmic dawn was wrong. The silence in the room grew as it became clear that the instrument was not lying. NIRSpec had captured a signal that defied the predicted pace of stellar evolution. They were looking at a mature powerhouse sitting in a time when there should have been nothing but primitive clouds of gas and darkness. The data showed a clear, sharp drop-off in the spectrum known as the Lyman break. This is the definitive signature of high redshift galaxies, where neutral hydrogen in the early universe absorbs all the light shorter than a specific wavelength, creating a cliff in the data. When that cliff appeared exactly where it should, for Z equals 1432, the reality sank in. JADES GGS Z1410 was not a fluke. It was there. It was real. And it was far more distant and luminous than any confirmed galaxy humanity had ever seen. The team sat with this realization, feeling the vertigo of deep time. They were no longer looking at a theory or a simulation. They were staring at an actual physical entity that had survived since the universe was barely 290 million years old. The sheer scale of it felt like a betrayal of the maps they had drawn. How could something so massive and bright have coalesced so quickly? The standard models suggested a slow, stumbling birth for the first galaxies, a gradual gathering of matter over hundreds of millions of years. But here was JADES GS Z1410, appearing fully formed and radiating with an intensity that shouldn't have been possible in such a young cosmos. The scientists found themselves staring at a graph that had just rewritten the history of light. NIRSpec's confirmation provided more than a distance. It issued a challenge. It was as if they had traveled back to the first few pages of a book and found a chapter already written in complex, mature prose when they expected only scattered letters. As they leaned closer to the screens, analyzing the fine details of that spectral line, they noticed something even more unsettling than the distance or the brightness. Hidden within the light, tucked into the frequencies captured by NIRSpec, was a chemical signature that should not be there. The air in the control room seemed to thicken as they stared at that jagged line on the monitor. It was a physical reaction, a collective holding of breath that lasted for minutes, perhaps hours, while the silence became its own presence. They were not just looking at data points or flickering pixels. They were witnessing the collapse of a timeline. For decades, the community had operated under a shared understanding of how the first light arrived. A slow, tentative awakening, where gravity spent eons coaxing thin veils of hydrogen into the first fragile embers of stars. Now, that entire narrative was being rewritten by a single spectral signature captured by NIRSpec. Imagine the feeling of standing on a shore you believed was the edge of the world, only to see a massive, luminous city shimmering on the horizon where there should have been nothing but an empty ocean. That is the vertigo these astronomers felt. The graph indicated more than a distant object. It proved the universe reached a level of complexity and maturity far earlier than simulations predicted. They found themselves questioning the very tools they had used to build their careers, wondering if the laws of cosmic evolution were not broken, but simply misunderstood. The team began to move in slow motion, as if the gravity of the discovery had physically slowed their steps. There was no shouting, no immediate popping of champagne. Instead, there was a profound, heavy stillness. They spoke in whispers, fearing that any sudden noise might shatter the fragile reality appearing on their screens. Every time they ran the reduction process again, every time they scrubbed through the raw data from the spectrograph to ensure no stray cosmic ray had mimicked a signal, the result remained the same. The cliff of the Lyman break was there, steep and undeniable, cutting through the light like a blade. They began to discuss the implications in low tones, their voices reflecting a mixture of awe and genuine distress. To accept this redshift meant accepting that the early universe was not a quiet nursery, but a frantic forge. It meant that while the models predicted a lonely, dark expanse, there were actually powerhouses like JADES GS Z1410 already radiating with an intensity that defied logic. The scientists felt as though they had discovered a fully grown oak tree in a forest that was supposed to consist only of seeds and sprouts. They spent hours tracing the line of the spectrum with their fingers on the glass, following the curve of light that had traveled for over 13 billion years just to reach this specific moment of human observation. They were touching the ghost of a galaxy that existed when the cosmos was in its absolute infancy. Yet it looked back at them with the confidence of an ancient entity. The dissonance was overwhelming. How could gravity have worked so fast? How could matter have clustered with such violent efficiency in those first few 100 million years? As they sat in the dim light of their workstations, the magnitude of the betrayal by their own maps became clear. They had spent years drawing a map of the cosmic dawn that was neat and orderly, a gradual climb from darkness to light. But JADES Z14-0 was an anomaly that tore through those lines. It sat there in the deep field, luminous and stubborn, refusing to fit into the boxes they had built for it. The team looked at a galaxy and saw a certainty die. They realized that the early universe was far more chaotic, far more aggressive, and infinitely more brilliant than they had ever imagined. The silence eventually shifted from shock to a deep, meditative curiosity. They were no longer trying to prove the data wrong. They were now trying to imagine a universe where such a thing was possible. They leaned into the mystery, letting the vertigo wash over them, accepting that they were staring at a piece of history that should not exist. And as they looked closer, peering into the depths of those captured frequencies, they realized the distance and the brightness were only the beginning of the impossibility. There was something else hidden in the light, a secret written in the chemistry of the stars, waiting to be decoded by their trembling hands. The signal from NIRSpec was not just a measurement of distance, but a chemical confession. As the team parsed the data, they found a specific dip in the light, a precise frequency that could only belong to one thing: oxygen. The detection of oxygen in the spectrum of JADES Z14-14 was a shock that rippled through the room because it represented an impossible timeline. To find oxygen is to find the remains of a dead star. Expectation, a universe consisting almost entirely of hydrogen and helium, the raw and simple gases left over from the Big Bang. Reality, a galaxy already enriched with heavy elements, while the cosmos was only 290 million years old. The chemistry of the universe follows a strict, violent hierarchy. In the beginning, there were no metals, no oxygen, no carbon, no iron. There was only the primordial mist of the lightest elements. To create something as complex as an oxygen atom, you need the crushing pressure and unimaginable heat found only in the core of a massive star. You need a stellar engine that can fuse helium into heavier nuclei over millions of years. And then, most importantly, you need that star to die. You need it to explode in a supernova, scattering those newly forged elements across the void so they can be swept up by the next generation of stars and galaxies. But JADES Z14 was appearing at a time when there should not have been enough time for this cycle to complete. The universe was barely 290 million years old. Yet here was oxygen, etched into the light captured by NIRSpec. This meant that before this galaxy even became visible to us, an entire generation of stars had already lived their full lives and vanished. An invisible population of first stars, the legendary population 3 stars, must have ignited in the absolute darkness, burned through their fuel with terrifying speed, and died in colossal explosions to seed the gas clouds of JADES Z14-0. What does it mean for a galaxy to be mature before the universe itself has found its footing? The astronomers looked at the oxygen signature and realized they were seeing the second or third act of a play when they thought they were watching the opening scene. The presence of these metals indicates that the process of cosmic enrichment was not a slow, steady climb. but a sprint. The first stars must have been monsters, massive, luminous entities that lived fast and died young, forging the elements of life in a fraction of the time we once believed necessary. The team didn't celebrate immediately. Instead, they checked the calibration of the instruments again. They looked for any possible contamination, any glitch in the spectrograph that could mimic the signature of oxygen. But the line remained. The data was stubborn. JADES Z140 was telling us that the early universe was not a quiet nursery, but a frantic laboratory of nuclear fusion. It is a strange sensation to realize that the elements inside your own lungs, the very oxygen you are breathing right now, have a history that stretches back further than our models allowed. The atoms in our bodies were forged in the hearts of stars, and JADES Z140 proves that this factory was open for business almost immediately after the dawn of time. We are looking at a galaxy that had already mastered the art of stellar death, while the rest of the observable universe was still struggling to wake up from its dark ages. The oxygen is a ghost. It is the chemical fingerprint of stars that died billions of years before the Earth was even a thought in the void. Detecting this element allowed NIRSpec to locate more than a galaxy. It provided direct evidence of the universe's first fires. We cannot see those first stars because they are gone, vanished into the depths of time, but their legacy is written in the light of JADES Z140. This discovery forces a complete recalibration of how mass accumulates in the void. If oxygen existed at Z equals 14.32, then the transition from a sea of hydrogen to a complex cosmos happened with a speed that borders on the impossible. The universe was not drifting slowly toward complexity. It was rushing. It was as if the laws of gravity and fusion were working in overdrive, pulling matter together into dense knots and igniting them before the cosmic clock had even ticked through its first few 100 million years. We find ourselves staring at a spectral line that acts as a bridge to those missing ancestors. We are seeing the ashes of the first stars, preserved in the glow of a galaxy that shouldn't exist. The oxygen is not just a chemical detail, it is a witness. It tells us that the darkness of the early universe was shorter than we imagined, and the light was more aggressive than we dared to predict. As the team sat with this evidence, they began to wonder about the sheer volume of stars that must have perished to create such a detectable amount of oxygen in so little time. They were no longer just looking at one distant object, but imagining an entire lost epic of cosmic violence and creation. The luminosity of JADES Z140 was not just coming from the stars we see now, but was fueled by the debris of everything that came before it. And yet, while the oxygen tells us about the death of the first stars, it leaves a haunting question about what those ghosts actually looked like. Reach out into the void and feel the temperature drop. Imagine the cold not as a lack of heat, but as a physical weight pressing against your skin. An absolute stillness that stretches for millions of light years in every direction. In this frozen silence, there is no wind, no sound, and no warmth, only the crushing emptiness of a universe that has barely begun to wake up. And yet, drifting within this immense dark is JADES Z140, a speck of brilliance so concentrated it feels like a puncture wound in the fabric of the night. When we look at our own home, the Milky Way, we see a sprawling disk of stars, a vast galactic city spanning 100,000 light-years across, with arms that curve gracefully into the deep. We are used to this scale of grandeur, this sense of cosmic breathing room where stars have space to drift and orbit in slow, majestic circles. But JADES Z140 does not follow these rules of architecture. The data from JADES reveals a physical size, that is startlingly compact compared to the galaxies we see in our local neighborhood. It is not a sprawling metropolis of stars, but rather a dense, shimmering knot of matter. If the Milky Way is a vast continent, this early galaxy is a single, crowded city block, packed with an intensity that defies our modern intuition. Everything is closer. The stars are huddled together in a tight, luminous cluster, forging their light in a space so small it seems impossible for such power to be contained. How can something so physically small produce a luminosity that rivals the giants of the later universe? We find ourselves contemplating this strange density, imagining what it would be like to drift through those first crowded star fields. In our local sky, the distance between stars is an ocean of nothingness. But in JADES Z414-0, the neighbors are close enough to feel their heat. It is a concentrated engine of creation, a miniature powerhouse where gravity has pulled gas and dust into a focal point of extreme pressure. The scale is inverted. While it lacks the physical breadth of the galaxies we know, it possesses a brilliance that screams across 13 billion years of space. The compact nature of this galaxy tells us that the early universe was not interested in sprawling gardens or slow growth. It was an era of violent efficiency. Matter did not drift lazily into place. It collapsed with a suddenness and force that we can barely simulate in our laboratories. The sheer density of stars within such a small volume suggests a gravitational hunger, a drive to assemble mass as quickly as the laws of physics would allow. We are seeing a version of galactic birth that is alien to us. We see a world where the distance between the first suns was a fraction of what it is today, creating an environment of intense radiation and overlapping stellar winds. This compact size acted like a pressure cooker for chemistry, accelerating the cycle of life and death for the stars within. Because they were so close together, the influence of one dying star could more easily seed its neighbors with the heavy elements we detected in the spectrum. The oxygen did not have to travel far to find a new home. It was simply breathed out into a crowded room. This spatial compression creates a haunting image of the early cosmos. We often imagine the dawn of time as a thin, expanding mist of hydrogen. But JADES Z14-0 proves that there were islands of extreme density hidden within that mist. These were not just galaxies, they were cosmic needles, piercing through the darkness with an intensity born of their own confinement. The smaller they were, the more fierce their glow became, turning these compact knots into beacons that could be seen from the other side of the observable universe. We feel a sense of vertigo when we compare the sprawling elegance of Andromeda or our own Milky Way to this tight, brilliant spark. It is as if we are comparing a modern city to a prehistoric campfire, small in footprint, but the only source of warmth and light in an infinite, freezing wilderness. The compact size of JADES Z14-0 is the signature of a universe in a rush, a cosmos that was not waiting for the slow passage of eons to build its first monuments. As we drift away from this shimmering knot of stars, leaving the dense heat of its core behind and returning to the absolute cold of the surrounding void, we are left with the realization that time itself was moving differently back then. The speed at which this galaxy assembled its mass, the rate at which it packed its stars into such a small volume, suggests a timeline that our current models struggle to explain. The compact size is not just a physical attribute, it is a clue to a lost rhythm of creation. It points toward an era where the first fires were lit with a frequency and intensity that we are only now beginning to perceive. The silence of the void was broken not by a slow awakening, but by sudden, brilliant bursts of light that ignited in tight clusters across the darkness. And as we follow those lines of light back through the depths of time, we begin to trace the exact timeline of the first fires. To grasp the presence of JADES NIRSpec we must first settle into the silence of a universe that was approximately 290 million years old. In the grand chronology of the cosmos, this is not even a blink, but a fraction of a heartbeat after the beginning. At this specific age, the universe was a fragile place, a vast and cooling ocean of primordial gas where the very concept of a galaxy should have been an impossibility. The space between everything was expanding, pulling the remnants of the Big Bang into a thin, cold veil, leaving behind a darkness so absolute that it felt permanent. This was the era of the cosmic dawn, a period defined by a slow, agonizing wait for gravity to pull enough matter together to ignite the first sparks of fusion. The birth of light in such an environment is not something that happens quickly. It requires a precise and patient collapse of hydrogen and helium, falling inward over millions of years, compressing under its own weight until the core reaches a temperature where atoms fuse. In our current understanding of time, this process was supposed to be a gradual awakening. We imagined the first stars as lonely wanderers, appearing one by one in isolated pockets of gas, flickering like distant candles in a windswept void. For millions of years, these solitary fires would have been the only things existing in the dark, slowly enriching their immediate surroundings with the first traces of heavier elements before they eventually collapsed and died. But when we look at JWST Z14-0, we are not seeing a lonely candle. We are seeing a bonfire. At an age of approximately 290 million years, this galaxy had already managed to assemble a massive population of stars, burning with a brilliance that defies the slow rhythm of the early cosmos. It is as if we walked into a prehistoric forest and found a fully functioning city made of glass and steel, existing long before the first stone tool was ever carved. The light emitted by this entity was not the tentative glow of a few newborn stars. It was the roar of a mature stellar powerhouse, radiating energy across the void with an intensity that suggests a frantic, accelerated birth. The scale of this acceleration is difficult to process without feeling a sense of cosmic vertigo. In those first 290 million years, JWST Z14-0 did not just exist, it thrived. It managed to gather enough baryonic mass to create a gravitational well deep enough to trap immense quantities of gas, fueling a star formation engine that operated at a speed we rarely see in the modern universe. While the rest of the cosmos was still drifting in a state of primordial slumber, this single point of light had already leapt forward through several stages of evolution. It had skipped the tentative steps of the first stars and jumped straight into the creation of a luminous system. If you could drift through that era, you would find yourself in a universe where the horizon was almost entirely black. You would travel for millions of light years without seeing a single photon of light, moving through a ghost sea of neutral hydrogen. And then, suddenly, you would encounter JWST Z14-0. It would appear as a brilliant, compact jewel suspended in an infinite ink, its light cutting through the fog with a piercing clarity. This was not a slow emergence from the darkness, but a sudden eruption. The galaxy acted as a beacon, ionizing the gas around it and carving out a bubble of transparency in the opaque mist of the early universe. This process of rionizing the surroundings is one of the most violent and transformative events in cosmic history. As the intense radiation from JWST Z14-0 streamed outward, it stripped electrons from hydrogen atoms, turning the neutral fog into a plasma that could finally allow light to travel freely. The galaxy was not just living in the universe. It was actively reshaping the environment around it, acting as an architect of the void. Every photon escaping its core was a hammer blow against the darkness, pushing back the boundaries of the cosmic dark ages and announcing that the era of structure had arrived much sooner than anyone anticipated. The sheer existence of such a system at 290 million years creates a tension in our maps of time. We are forced to ask how gravity could have worked so efficiently in such a short window. How did the gas find its way into this specific location with such precision and speed? The standard models suggest that mass accumulates slowly, like snow drifting into a pile over a long winter. But JADES GS looks less like a drift of snow and more like an avalanche, a sudden, catastrophic collapse of matter that bypassed the usual waiting periods of cosmic evolution. This suggests that in the very earliest moments of existence, there were mechanisms for growth that we still do not fully comprehend. Perhaps the density fluctuations in the early universe were more extreme than our simulations show, creating deep gravitational pits that acted as vacuum cleaners, sucking in everything within their reach at speeds that should be impossible. Or perhaps the first generations of stars lived and died with a rapidity that accelerated the chemical enrichment of space, providing the seeds for galaxies like JADES Z14 to ignite far ahead of schedule. As we linger in this ancient light, observing the glow of a universe at 290 million years, we realize that our timeline is not a straight line, but a series of surprises. The silence of the dawn was broken by an entity that should have been too young to be so bright, too early to be so massive, and too primitive to possess such intensity. It sits there in the deep field of the JWST, a shimmering contradiction that refuses to fit into the boxes we built for it. The more we stare at this distant spark, the more the old certainties begin to dissolve. We are left with the image of a galaxy that is not just an anomaly, but a challenge. It stands as a reminder that the cosmos does not always follow the rules of patience and gradual growth. Sometimes, it creates masterpieces in an instant, forging brilliance out of chaos before the clock has even truly started ticking. And yet, this maturity is exactly what makes its presence so troubling to our understanding of the first light. We are left wondering why we believed the early universe was a place of such slow and hesitant beginnings, when JADES Z14 proves that the cosmos was capable of an impossible maturity almost from the very start. The blueprints we drew for the early cosmos were painted in shades of gray and black. In those models, the period following the first light was a long, hesitant slumber known as the Cosmic Dark Ages. It was a time defined by an absence of fire, where the universe existed as a vast, cold ocean of neutral hydrogen and helium, drifting in a silence so profound that it seemed permanent. The prevailing consensus held that the transition from this darkness to the first glimmer of starlight would be a slow, agonizingly gradual process. Gravity was expected to work with extreme patience, pulling together small pockets of gas into tiny, fragile clumps over hundreds of millions of years before any single star could ignite. The predicted timescale for initial baryonic mass accumulation suggested a cautious buildup. Matter was supposed to gather in modest amounts, forming the first miniature galaxies that were little more than dim smudges against the void. These early structures were thought to be primitive and sparse, lacking the density or the energy to shine with any real intensity. In this version of history, the universe was a nursery where the infants grew slowly, taking their time to breathe in the hydrogen mist before they could ever hope to forge something as complex as a galaxy. The math suggested that for several 100 million years, the cosmos would remain largely blind and empty, waiting for the slow drift of atoms to finally reach a critical mass. But when we look at JADES Z14, that entire timeline begins to fray. We are seeing an entity that does not behave like a hesitant infant. It behaves like a mature powerhouse. If the old consensus was a story of gradual awakening, this galaxy is a sudden, blinding shout in the middle of a silent room. It exists at a moment when the universe should have still been gathering its strength, yet it possesses a luminosity and a structure that suggests it has already mastered the art of star formation. How did the clock move so fast for this one corner of space? We find ourselves staring at a contradiction in timing. The models told us that baryonic mass, the ordinary matter that makes up stars and planets, would take much longer to accumulate into something as massive and bright as what we see here. There was supposed to be a gap, a long stretch of time where the universe was too thin and too hot for such rapid growth. Yet JADES Z14-0 sits there, 290 million years after the beginning, having already bypassed the slow climb that every other theory predicted. It is as if we expected to find a small village in the wilderness, but instead, we stumbled upon a sprawling metropolis of light, fully functional and humming with energy, long before the roads were even built. This discrepancy forces us to reconsider the very nature of gravity in the early dawn. Perhaps the pull of matter was not a gentle drift, but a violent surge. Maybe there were regions of space where the density was so high that they acted as cosmic accelerators, condensing gas and forging stars at rates that our current simulations cannot replicate. The quiet slumber of the Dark Ages may have been interrupted by these pockets of intense activity, creating islands of brilliance while the rest of the universe still slept in the gray mist. The presence of this galaxy suggests that the early universe was not a uniform nursery, but a place of extreme contrasts. While much of space remained dark and empty, JADES Z14-0 proves that some areas were already rushing toward maturity. It challenges the idea that there was a universal speed limit for how quickly mass could accumulate. The timeline we relied on, the one that spoke of slow growth and hesitant beginnings, is no longer sufficient to explain what is staring back at us through the lenses of the JWST. We are left with the unsettling realization that our cosmic calendar might be wrong. We mapped out the first few 100 million years as a period of preparation, a long breath held before the first spark. But JADES Z14-0 reveals that the spark had already become a wildfire in some places. The maturity of this galaxy is not just an anomaly. It is evidence that the universe was capable of achieving massive scale and intense luminosity far earlier than any theoretical model allowed. It makes us wonder if we have been underestimating the urgency of the cosmos. We imagined a slow dawn, but we are discovering a sudden sunrise. The baryonic mass did not just accumulate, it surged. It did not just drift. It collided and collapsed with a ferocity that bypassed millions of years of predicted evolution. Every photon reaching us from this distant source is a piece of evidence against the old order of things. The silence of the Dark Ages was not as absolute as we believed. There were fires burning in the deep, forging heavy elements, and lighting up the void, while the rest of the cosmos was still shrouded in neutral gas. The existence of JADES Z14-0 acts as a rupture in our understanding, a point where the predicted timeline simply breaks apart under the weight of observed reality. We are no longer looking at a slow awakening. We are looking at an impossible acceleration. And as we analyze the data further, we find that this is not just about how much mass was there, but how that mass converted itself into light with such terrifying efficiency. The evidence is no longer subtle. It is written in the spectrum of a galaxy that refuses to obey the clock. The light reaching us from JADES Z14-0 carries a specific, violent energy that contradicts the stillness we once attributed to the early universe. When the data is processed and the redshift is stripped away, astronomers find an intense emission of rest-frame ultraviolet light. This is not the soft glow of a few lonely stars drifting in a void, but the searing radiance of massive star formation happening on a scale that should be impossible for its era. Rest-frame UV light is the fingerprint of youth and heat. It only emerges from the hottest, most massive stars, blue giants that burn through their nuclear fuel with a desperate intensity, living fast and dying young. To see this specific signature in a galaxy existing only 290 million years after the beginning is to realize that JADES Z14-0 was not merely waking up. It was already screaming into the darkness. This ultraviolet surge tells us that the star-forming engine inside this galaxy was running at full throttle. In the standard models of cosmic evolution, the first galaxies were expected to be small, dim, and hesitant. They were supposed to be fragile collections of gas, slowly coalescing under the weak pull of gravity, taking their time to ignite the first generation of stars. But the rest-frame UV emission from JADES Z14-0 reveals a different story. It shows a powerhouse that had already mastered the art of stellar birth. The sheer volume of high-energy photons being pumped into the surrounding space suggests a rate of star formation that defies the clock. How does a galaxy achieve this level of luminosity so quickly? The UV light is an indicator of mass, but specifically, it is an indicator of massive stars. These are stars tens or hundreds of times larger than our Sun, burning with such ferocity that they ionize the hydrogen around them and carve out bubbles of transparency in the cosmic fog. When we look at this emission, we are seeing a factory of light working overtime. The universe was still in its infancy, yet here is an entity that has already built a metropolis of blue giants. The intensity of this UV radiation does more than just illuminate the galaxy. It transforms the environment around it. These photons were the hammers that broke the grip of the cosmic dark ages, pushing back the neutral hydrogen and beginning the process of reionizing the cosmos. JADES Z14-0 was not just a passive observer of this transition. It was an active participant, a lighthouse casting a beam across the void long before other galaxies had even learned how to shine. The evidence is etched into the spectrum provided by the JWST, showing a brightness that exceeds every prediction made by our current cosmological simulations. We often think of the early universe as a place of gradual growth, where complexity emerged slowly over billions of years. But this ultraviolet signature suggests a suddenness that is almost jarring. It implies that in certain pockets of space, gravity did not just pull matter together, it slammed it together with an efficiency we cannot yet explain. The rest-frame UV light is the evidence of that collision. It is the glow of a cosmic furnace that was stoked to maximum heat, while the rest of the universe was still shivering in the cold of the first few 100 million years. The presence of such intense radiation also means that these massive stars were already reaching the end of their short lives. For there to be this much UV light, thousands of generations of stars must have already flickered and died, seeding the galaxy with the heavier elements we detected in its spectrum. The timeline is compressed into a window so narrow it feels like an error. We are seeing the result of millions of years of stellar evolution packed into a fraction of that time. The engine was not just running, it was overclocked. This creates a tension in our understanding of how matter behaves at the edge of time. If JADES Z14-0 could produce this much light and forge so many stars so quickly, then the early universe was far more volatile than we imagined. It was not a quiet nursery, but a chaotic arena where massive structures were forged in an instant. The rest-frame UV emission is the smoking gun of this acceleration. It proves that the capacity for brilliance was present from the very start. waiting only for enough mass to gather before erupting into existence. The photons we detect today have traveled across 13 billion years of expanding space, stretching and shifting until they reached the infrared sensors of the JWST. But when we mathematically shift them back to their original state, we find that blinding ultraviolet glare. It is a postcard from a time of extreme energy, a reminder that the dawn of the universe was not a slow sunrise, but a sudden flash of light that tore through the darkness. We are forced to ask what kind of conditions could possibly foster such an explosion of growth. The models suggested a slow accumulation of gas, a gentle drift toward density. But JADES Z14.0 suggests something more aggressive. It suggests that the early universe had mechanisms for concentrating mass and igniting stars that we have yet to discover. The UV light is not just a measurement, it is a challenge to our theories of how everything began. As we stare into this distant glow, we realize that luminosity is only half of the mystery. While the light tells us about the heat and the youth of the stars, there is another factor that remains stubbornly unexplained. The brilliance of the UV emission requires a certain amount of fuel, a vast reservoir of gas and dust to feed the star-forming engine. And when we attempt to calculate how much matter must be present to sustain such an intense output of light, the numbers begin to shift into something truly unsettling. And yet, the scale of its mass is even more troubling. When the data from JADES Z14.0 first arrived, it did not feel like a discovery. It felt like an error. The astronomers who processed these signals did not celebrate immediately. Instead, they went very quiet. They looked at the numbers on their screens and then looked back at the models they had spent their careers refining. There is a specific kind of silence that falls over a research team when the evidence contradicts the fundamental laws of the field. It is the sound of an entire map being erased in real time. The team began to recalculate. They ran the scripts again, checking for noise in the NIRSpec data, searching for any possible glitch in the instrument that could have mimicked such a signal. They checked the calibration once, then twice, and then a third time. Each pass through the calculations yielded the same impossible result. The galaxy existed, and its mass was overwhelming. The estimated stellar mass of JADES Z14.0 is significantly larger than any of its predicted contemporaries from that era. In the standard models of cosmic evolution, a galaxy existing only 290 million years after the Big Bang should be a fragile thing, a loose collection of gas, and perhaps a few scattered clusters of early stars. It should have been a seed, small and underdeveloped, struggling to hold on to its matter against the expanding void. But JADES Z14.0 is not a seed. It is a forest. The mass we are seeing suggests a maturity that defies the clock. To reach this level of stellar density so quickly, the galaxy had to have converted vast amounts of primordial gas into stars at a rate that shouldn't be possible in such a young universe. The astronomers found themselves staring at a contradiction. The age of the cosmos was too short for the mass they were measuring. It is as if you walked into a nursery and found a newborn baby with the physical stature and weight of a grown man. This discovery creates a profound tension in our understanding of gravity and time. For matter to clump together into such a massive entity, it requires an immense amount of gravitational pull and an incredible speed of collapse. The team had to confront the fact that the early universe was far more efficient at building structures than anyone had dared to hypothesize. They were not looking at a slow accumulation of dust, but a violent, accelerated assembly of stars. The disbelief persisted because this mass implies a hidden history. For JADES Z14.0 to be this massive, there must have been an even earlier period of growth that we cannot yet see. It suggests that the very first stars ignited almost immediately after the darkness ended, working in overdrive to build the foundation for this behemoth. The researchers were no longer just measuring a galaxy. They were tracing the fingerprints of a lost epoch of creation that happened faster than our math allowed. We are forced to realize that our timeline of the early universe is missing entire chapters. We thought we knew how long it took for gravity to win its battle against expansion, but this single object proves that victory happened much sooner and with far more intensity. The mass of JADES Z140 acts as a physical anchor, pulling our theories backward and forcing us to admit that the dawn was not a gradual waking, but a sudden, massive eruption of matter. As you lie there in the stillness, try to feel the weight of it. Not the weight of your own body, but the crushing density of billions of suns packed into a space so small it would be a mere speck in our own local neighborhood. It is a concentration of energy and matter that feels almost predatory in its intensity, defying the emptiness that surrounded it on all sides. The sheer amount of stellar material present in JADES Z140 suggests a density that challenges the very nature of how gas behaves under extreme pressure. We are seeing an impossible gathering of light and heat, compressed into a compact volume that belies its own scale. This is not just a large galaxy for its time. It is a gravitational anomaly that refuses to fit into the old boxes of cosmic growth. And yet, this density is only the beginning of the mystery, because when we look at how those stars are packed together, the image becomes even more surreal. To grasp this density, we have to move away from the maps of modern space and think in terms of pure, concentrated pressure. Think of a city where every single building is replaced by a star, a metropolis of fire stretching for miles in every direction. Now, imagine that entire city being crushed down, compressed with an unthinkable force until it fits onto the head of a needle. That is the scale we are dealing with in JADES Z140. It is not just a collection of stars. It is a stellar horde, a crowded sanctuary of light where suns are packed so tightly together that their gravitational fields overlap and intertwine in a chaotic dance. In our own neighborhood, the space between stars is a vast, freezing ocean of nothingness. But here, at the edge of the observable dawn, the void has been evicted. The luminosity we detect from this object suggests a concentration of matter that should be impossible for its era. We are looking at billions of suns occupying a fraction of the volume we would expect for such a mass. It is as if the universe decided to build an entire empire in a single room, forcing everything into a compact, shimmering core of extreme energy. How could so much matter gather so quickly? The answer lies in a terrifyingly efficient engine of creation. The data reveals that the star formation rate within JADES Z140 was not merely active, it was accelerated to a degree that defies our standard models of cosmic growth. While we expected the first galaxies to flicker into existence like distant candles, slowly accumulating gas over hundreds of millions of years, this galaxy was more like a supernova in slow motion. It was forging stars at a pace that suggests an almost violent urgency, as if it were racing against time itself to claim every atom of hydrogen available in its local region of space. The sheer volume of new suns being born every year within this compact radius creates a feedback loop of heat and radiation. This accelerated star formation means the galaxy was consuming its fuel with a hunger that should have exhausted it quickly. Yet it remained luminous, a powerhouse of ultraviolet energy screaming across the void. It is an industrial-scale production of light occurring in a universe that was still technically in its infancy. If you were to drift near the edges of this system, you would not see the slow, serene rotation of a spiral galaxy like our own. You would witness a frantic, crowded furnace where stars are born and die in rapid succession, their life cycles compressed by the overwhelming density of the surrounding gas. The energy output is so intense that it creates a pressure wave, pushing back against the very vacuum of space. We have to ask ourselves, what kind of environment allows for such an explosion of growth? What invisible hand guided these billions of tons of gas into such a tight, efficient knot only 290 million years after everything began? The math suggests that JADES Z14 did not follow the rules of gradual assembly. It didn't wait for smaller clusters to merge over eons. Instead, it seems to have collapsed from a massive primordial cloud in one singular, catastrophic event of creation, igniting its stars all at once in a flash of cosmic brilliance. This is the true nature of the anomaly. The acceleration of its birth suggests that our understanding of how gravity works in the early universe is incomplete. We thought we knew the speed limit for building a galaxy, but JADES Z14 broke that limit before it even had a chance to settle into a stable shape. It represents a shortcut in cosmic evolution, a leap from nothingness to maturity that bypasses the slow climb we see in later epochs. The resulting object possesses a staggering intensity that dominates its entire environment. This concentration of mass and light creates a gravitational well so deep that it bends everything around it, acting as a beacon in a universe that was otherwise struggling to wake up from the dark. The heat generated by this accelerated birth is not contained. It leaks out into the surrounding emptiness, carving a bubble of ionized gas through the primordial mist. As we look at this needlepoint city of stars, we realize that JADES Z14 was not an isolated miracle. It was a catalyst. The energy pouring out of its compact core began to bleed into the darkness, altering the chemistry and temperature of everything in its vicinity. This single point of light started to push back against the void, creating a ripple effect that would change the fate of the surrounding space forever. The discovery of JADES Z14 does more than just break a record for distance. It forces us to redraw the map of how the first light actually entered the void. For a long time, our models suggested that the transition from a dark universe to one filled with stars was a slow, hesitant awakening. We envisioned a period where the first few lonely stars flickered into existence, fighting against an oppressive fog of neutral hydrogen that swallowed almost every photon they produced. But this galaxy proves that the dawn was not a gradual sunrise. It was a sudden, violent ignition. At Redshift Z1432, JADES Z14 is operating in a universe that is still fundamentally opaque. This is where we encounter the process of reionization. In those first few 100 million years, the entire cosmos was filled with a thick, cold mist of neutral hydrogen gas. This gas acted like a cosmic curtain, blocking the path of light and keeping the universe in a state of profound blindness. For any star to be seen across the void, that curtain had to be torn down. The energy required to strip electrons from hydrogen atoms to ionize the gas and make the universe transparent is immense. It requires an onslaught of high-energy ultraviolet radiation. We used to think this process was driven by a vast population of small, faint galaxies working in unison over hundreds of millions of years. But JADES Z14 suggests a different story. This single, luminous powerhouse is producing so much intense radiation that it is carving its own sanctuary out of the darkness. It is not waiting for the universe to become transparent. It is forcing the transparency to happen. Imagine the sheer pressure of those photons pushing outward from the compact core of JADES Z14. The ultraviolet light screams into the surrounding neutral hydrogen, stripping away its electrons in a relentless wave of energy. Around this galaxy, the fog is lifting. A bubble of ionized space is expanding, growing larger and clearer as the stars within continue to burn with an intensity that defies their age. This is reionization in real time, a localized war between light and shadow, where the light is winning far faster than any model predicted. How many other beacons were flickering in the dark at Zeven 14.32? Unseen simply because they weren't as massive or as bright as this one. The existence of JADES Z14.0 implies that the early cosmos was not a quiet nursery, but a landscape dotted with these high-energy engines, each blowing its own bubble in the primordial mist. As these bubbles grew and eventually touched, they merged into vast oceans of ionized gas, finally clearing the way for the light we see today to travel across billions of light years without being absorbed. This shift in perspective changes everything about the first billion years. The Dark Ages were not a monolithic block of silence. They were interrupted by these bursts of impossible maturity. We are seeing that the universe had the capacity to organize matter into massive, luminous structures almost immediately after the Big Bang. The efficiency with which JADES Z14.00 converted gas into stars suggests that gravity in the early universe was perhaps more aggressive, or that the conditions for star birth were far more favorable than we ever dared to assume. We are no longer looking at a slow climb toward complexity. We are looking at a leap. The process of reionization, once thought to be a gentle transition, now looks like a series of explosive events driven by anomalies. JADES Z14.0 is the evidence that the first light was not a whisper, but a shout that echoed through the neutral hydrogen, signaling the end of the cosmic night and the beginning of the era of galaxies. The impact of this discovery ripples backward to the very first seconds of time. If such a massive entity could exist only 290 million years after the start, it means the seeds of structure were planted deeper and grew faster than our math allowed. The universe was not just expanding, it was rushing toward maturity with an urgency that we are only now beginning to perceive through the infrared lens of the JWST. As we watch this distant light, we realize that JADES Z14.0 is a survivor of a forgotten epoch. It represents a time when the laws of growth were different, and where the struggle for transparency defined the fate of every atom in existence. The bubble it carved into the void was one of the first breaths of the observable universe, a clearing in the woods that allowed the rest of cosmic history to be written in light. And yet, as we contemplate this powerhouse of the early dawn, we must ask what became of it. This galaxy is not a static image. It is a snapshot of a youth spent in an environment of extreme violence and rapid change. It existed at the very edge of the possible, pushing against the limits of physics to exist when it should not have. The light that left JADES Z14.0 has traveled for more than 13 billion years, crossing a universe that was expanding and cooling around it. While those photons were in flight, the galaxy itself continued to age, to merge, and perhaps to fade. It shifted from being an impossible anomaly at Zeven 14.32 to becoming part of the larger, slower dance of cosmic evolution. We are seeing the ghost of a pioneer, a city of stars that woke up before the rest of the cosmos was even awake. Its luminosity told the universe that it was time to turn on the lights, and in doing so, it paved the way for everything that followed, including the very atoms that now make up our own bodies. This is where JADES Z14.0 settles into its place, within the long, silent sleep of time. The light we see from JADES Z14.0 is a postcard sent across an ocean of time, but the galaxy that sent it did not remain frozen in that moment of impossible brilliance. To classify this object as a high redshift galaxy is to identify it as a pioneer, a celestial seed planted in the most fertile and violent soil the universe has ever known. But seeds are meant to grow, and for JADES GGS Z14b0, growth meant an evolutionary path of relentless consumption and transformation. As the millions of years passed after that snapshot at ZR14-32, this compact powerhouse would have felt the gravitational pull of its neighbors. In those early epochs, the cosmos was a crowded place, not in terms of distance, but in terms of influence. The high redshift classification tells us that JADES GSS Z14-0 was an outlier, a massive entity in a universe of infants. This disparity in mass acted like a cosmic magnet. Over the next few 100 million years, this galaxy likely began a series of mergers, drawing in smaller clouds of gas and perhaps other nascent star clusters that were drifting through the reionizing fog. Each merger was not a gentle union, but a collision of titanic proportions. Imagine the shock waves rippling through those first generations of stars as new material crashed into the galactic core, triggering bursts of star formation even more intense than what we observed in the rest frame ultraviolet light. The galaxy would have grown larger and more complex, shifting from that needlepoint density toward a structure that resembled the early ancestors of our own Milky Way. It was moving along an evolutionary trajectory where mass begets mass, turning its initial anomaly into a foundation for everything that followed. As billions of years stretched out, the frantic pace of the cosmic dawn began to slow. The universe expanded, pulling galaxies further apart and cooling the primordial fires. JADES GS Z14-0 would have transitioned from a blue, luminous powerhouse into a more mature system. Its most massive stars, those that forged the oxygen we detected in its spectrum, lived fast and died young, exploding as supernovae that seeded the surrounding space with iron, carbon, and silicon. The galaxy became a chemical factory, refining the raw materials of existence through cycles of stellar death and rebirth. We can trace this path conceptually, seeing how a high redshift galaxy evolves into a local one. It likely spent eons spiraling, merging, and perhaps settling into a quiet elliptical shape or a grand rotating disk. The intense luminosity that once defied our cosmological models would have faded into a steady amber glow of older stars, the kind of light that no longer screams its presence across the void, but whispers it to those who know where to look. But as we follow this trajectory forward in time, a quiet uncertainty emerges. We see the beginning, the impossible brilliance at 290 million years. But the middle and the end are lost to the sheer scale of deep time. Did JADES GS Z14-0 survive the chaotic mergers of the adolescent universe? Was it swallowed by an even larger predator, its stars scattered into a greater halo of light? Or does it still exist today, perhaps as a quiet neighbor in our own local group, disguised by billions of years of aging and evolution? What became of that first great city of stars? It is possible that the very atoms forged in those early, accelerated bursts of star formation are now part of the dust on a distant moon or the iron in a nameless planet's core. The galaxy may have vanished as a distinct entity, but its legacy was written into the chemistry of the cosmos itself. Its existence proved that the universe could build complexity far faster than we ever dared to calculate, leaving behind a trail of heavy elements that would eventually allow for the birth of rocky worlds and the emergence of life. The evolutionary path of JADES GS Z14-0 is a mirror of our own history. It began as an impossibility, grew through struggle and collision, and eventually settled into the long, slow rhythm of cosmic maturity. We are looking at the youth of a giant, seeing it before it learned how to be quiet. before it became part of the background radiation of a cooling universe. And yet, even with this map of its probable future, we are left staring at a gap in our knowledge. We have the start, and we can guess the end, but there is a silence between them that no current telescope can fully bridge. We possess the record-breaking redshift, the chemical signatures, and the mass estimates, but these are only isolated points on a vast timeline. The image provided by the JWST is a masterpiece of precision, yet it reveals how much we are still missing. Every answer JDAAAS provides seems to create 10 new questions about the nature of gravity and time in the first few 100 million years. We have found the anomaly, but we have not yet found the rule that governs it. The pieces are there, scattered across the infrared sky, waiting for a lens sensitive enough to gather them. But as we look closer at the data, we realize that the most important parts of the story might be the ones that are entirely invisible to us. The light from JADES GS-14 does not arrive as a simple glow, but as a coded message written in the language of spectra. When the data flows through the NIRSpec instrument, it reveals a specific, abrupt signature known as the Lyman break. This is not a gradual fading of light, but a sharp cliff where the spectrum simply vanishes at a certain wavelength. It happens because the neutral hydrogen filling the void between us and that distant galaxy absorbs almost every photon of ultraviolet light below a precise threshold. The Lyman break is the cosmic fingerprint of distance, a definitive wall that tells astronomers exactly how far back into the dawn they are looking. Seeing this break in the spectrum was the final confirmation that JADES GS-Z14 was not an optical illusion or a foreground contaminant, but a genuine inhabitant of the deep past. And yet, even with this fingerprint, the mystery only deepens when we ask what came before it. We have found a mature city of stars at 290 million years, but where are the villages that preceded it? There is a missing generation of cosmic seeds, the very first clumps of mass that had to collapse from the primordial mist long before JADES GS-Z14 could ever ignite. These earliest structures would be far smaller, dimmer, and more elusive than any galaxy we have yet recorded. They are the ghosts in the machine of early cosmology, existing in a regime where gravity was just beginning to win its war against the expansion of space. The current deep fields captured by the JWST are like small holes poked through a heavy curtain, giving us glimpses of an impossible maturity. But as we push the limits of integration time, staring at the same patches of blackness for hundreds of hours, we are searching for those first seeds. We are looking for the transition point where a cloud of hydrogen becomes a star, and where a cluster of stars becomes a galaxy. If JADES GS-Z14 is the result of an accelerated birth, then there must be evidence of that acceleration written in the spaces between the galaxies we can already see. What does it take for the universe to organize itself so quickly? We are forced to wonder if our understanding of how dark matter pulls gas into these early wells is incomplete. Perhaps the first seeds were larger than we thought, or perhaps the cooling of primordial gas happened with a suddenness that defies our current simulations. Every new deep field image acts as a probe, searching for the moment when the darkness finally broke, and the first photons began to carve paths through the fog. We are now waiting for the next layer of data, the deeper exposures that might reveal the siblings of JADES GS-Z14 or perhaps its ancestors. These future observations will measure whether this galaxy was a lonely freak of nature or part of a widespread population of early giants. If we find more objects with similar masses and chemical signatures at such extreme redshifts, it means the entire timeline of cosmic dawn must be shifted backward. It would mean that the universe did not wake up slowly, but surged into existence with a violence and speed that we are only now beginning to quantify. The Lyman break tells us where the galaxy is, but it does not tell us how it got there so fast. It leaves us staring at a gap in the record, a silence that exists between the Big Bang and the appearance of these luminous powerhouses. We possess the evidence of the result, but the process remains hidden in the infrared shadows. The search for those first seeds is no longer just about finding more stars. It is about discovering the rulebook that allowed JADES as GSZ14-0 to exist when it should have been impossible. As we continue to refine our maps of the high redshift universe, the focus shifts from the sheer distance to the nature of the light itself. We are learning to read the subtle dips and rises in the spectrum as a history book of the first few 100 million years. Every photon that survived the journey across 13 billion years carries a piece of that missing story, provided we have the patience to listen to its whisper. But there is a limit to what an instrument can tell us about the object alone. Eventually, the data stops being about the galaxy and starts being about the eye that sees it. We have spent so long tracing the light back to its source that we have forgotten to look at the mirror reflecting it. The journey of the photon from JADES GSZ14-0 is half of the story, but the other half belongs to the observer waiting on a small, rocky world in the suburbs of a common spiral galaxy. The paradox of our existence begins with a simple, quiet contradiction. We are small things made of fragile carbon and water, confined to a single rocky sphere in a nondescript corner of a spiral galaxy. Our lives are measured in decades, our breaths in seconds, and our vision is limited to the thin sliver of light that can pierce through a nitrogen sky. Yet, here we are, using an instrument made of gold and beryllium to gaze across 13 billion years of void. We have reached out into the dark and touched JADES GSZ14-0. There is something profoundly unsettling about this act of perception. The distance between our eyes and that distant cluster of stars is so vast that it defies every biological instinct we possess. Our brains evolved to track predators in tall grass, or the movement of the moon across a night sky, not to process the arrival of photons that began their journey before the first atom of oxygen had even settled into a planetary crust. When we look at the data from JADES GSZ14-0, we are not seeing a place that exists in our present moment. We are witnessing a ghost. We are perceiving a version of the universe that has long since vanished, evolved, and shifted into something entirely different. This is the paradox of human perception versus cosmic scale. The observer is infinitesimal, but the observation is infinite. We possess a mind capable of constructing a mathematical bridge to a time when the universe was only 290 million years old. It means that for one brief flicker of cosmic time, the universe has developed a way to look back at its own birth. Through us, the cosmos is finally remembering where it came from. We are like children standing on the shore of an ocean we cannot possibly swim in, yet we have found a way to read the messages carried by the foam. The fact that a conscious mind can even conceive of a redshift of 14.32 is a miracle of biological and technological alignment. It requires a chain of events so specific: the cooling of a planet, the evolution of a primate, the discovery of electricity, the launch of a telescope into the L2 Lagrange point, that the mere act of seeing JADES GSZ14-0 feels like an impossibility in itself. Pause for a moment and feel the weight of your own breath. Feel the air moving in and out of your lungs, a rhythm that has continued since you were born. Now, try to hold that feeling while imagining those same atoms of oxygen being forged in the heart of a star nearly 13 billion years ago. The oxygen in your blood may have once been part of a generation of stars, just like the ones we see in JADES Z14-0. You are not merely observing the distant past. You are made of it. The scale of the universe usually makes us feel insignificant, as if we are nothing more than dust motes dancing in a beam of light. But there is another way to look at this reversal. If the universe is so vast and so ancient, then the fact that we can perceive it at all is the most extraordinary event in the history of space-time. The void is silent. The dark energy is blind. The black holes are mindless. Only we have the capacity to be amazed by them. We are the only part of this 13 billion-year story that has stopped to ask why the story is being told. We are the witnesses. When NIRSpec captures a dip in a spectrum, it is not the machine that understands the discovery. It is the mind behind the machine. The instrument provides the evidence, but we provide the meaning. This intersection, where cold silicon meets warm consciousness, is where the true mystery of JADES Z14-0 resides. It is a strange kind of vertigo to realize that our perception is the only thing giving the cosmos a voice. Without an observer, the light from the most distant galaxy would simply travel forever through the emptiness, never hitting a mirror, never triggering a sensor, never becoming a thought. It would be a scream in a vacuum where no one can hear. But we heard it. We caught those photons, and we translated them into wonder. We have spent our history looking up at the stars and wondering if we are alone. Perhaps the real question is not whether there are other minds out there, but how it is possible that any mind could emerge in a place so cold and indifferent. The existence of JADES Z14-0 proves that the universe was capable of creating massive, luminous structures almost immediately after the beginning. It suggests a cosmos that is eager to exist, a reality that rushes toward complexity with an urgency we are only starting to understand. And in that rush, we were eventually included. We are the end result of 13 billion years of gravity pulling matter together, stars exploding and seeding clouds of gas, and planets cooling into habitable spheres. Every single step of that process had to happen perfectly for us to be here tonight, listening to the story of a galaxy that shouldn't exist. The distance is no longer a barrier. It is a mirror. When we look at JADES Z14-0, we are looking at our own ancestry. We are seeing the first fires of a hearth that eventually warmed our world. The sheer scale of the gap between us and that distant light does not diminish us. It elevates us. It turns the act of thinking into a cosmic event. There is a quiet peace in accepting this imbalance. We do not need to be as large as a galaxy to understand its nature. We do not need to live for billions of years to appreciate the passage of time. Our brevity is what makes our perception so precious. A star that burns for 10 billion years never knows it is shining. Only a creature with a limited lifespan can look at a star and feel the ache of its beauty. We are the bridge between the beginning and the end. We stand in the middle of the timeline, looking back toward the dawn and forward toward the eventual silence. For a moment, we hold both ends of the thread. We see the impossible brightness of the early universe, and we feel the soft pull of the expanding void. As the data fades into the background and the numbers settle into their places on a screen, the intellectual curiosity begins to give way to something deeper. The science tells us how JADES Z14-0 exists, but the philosophy tells us why it matters that we are here to see it. We are the universe experiencing itself through a tiny, fragile window of consciousness. The light from 13 billion years ago has finally reached its destination. It has traveled across an ocean of nothingness to land on a piece of gold-plated mirror and then enter the mind of a human being. The journey is complete. The photon that left JADES GS-Z14-0 when the universe was a mere infant has finally found someone to tell its story to. Now, there is nothing left to calculate. There are no more redshifts to measure or spectra to analyze in this moment of reflection. We have pushed our vision as far as it can go, reaching the very edge of what is observable. Beyond that point lies a darkness we cannot yet pierce, and a silence we cannot yet hear. It is time to let go of the numbers. It is time to stop fighting the scale of the void and simply allow ourselves to be carried by it. The universe is vast, and we are small. And for now, that is enough. We can drift away from the evidence and the anomalies, leaving the galaxies behind as they recede further into the infrared distance. We surrender our need to know everything and instead embrace the peace of not knowing. We let the image of JADES GS-Z14-0 dissolve into a single point of light, then into a whisper, and finally into the stillness that existed before the first star was ever born. The record now belongs to JADES Z14-0, the most distant confirmed galaxy ever seen by human eyes as of 2024. It is a lonely beacon at the edge of everything we can know, a small point of light that refused to stay hidden in the dark. We leave it there, drifting in its own ancient time, while we return to the stillness of our own breath. Let the silence settle over us. Let the distance become a comfort. Let the count of stars keep growing in the quiet. Let us be the generation humble enough to listen to the ghost of a light that traveled 13 billion years just to find us. Sleep well tonight.